Cool. So I'm Alex. This is my second Go meetup and my first functional meetup. So it's nice to meet all you guys. Also, happy 1.6 release. Hey. Go. Is anyone using it yet?
I downloaded it.
Cool. Yeah, can't wait to start. Can't wait to start using HTTP too. So I'm just going to give a quick talk about my experience learning Go and writing a web service in Go, where my main database is a key value store. And specifically, I'm going to talk about how I went about designing my model layer and how I thought about it, how I came into it with preconceptions from how I did it with other programming languages. And just to get the terminology down, I know it's probably maybe not technically correct, but just for the purposes of this talk, when I'm talking about a model layer, all I mean is just a very blanket term. Just how do you represent your data, your domain models, and your application code? If, say, you have a business logic function, you have an account, and you need to change the email on that account, what kind of handler, what kind of object do you have a handler to, if any? And also maybe persistence, because it's common for model layers to bake in persistence into basically what they provide, ORMs, object relational mappers. A lot of their main function is to provide persistence for you as an easy way. And regardless of whether or not your model layer provides it for you, it's probably going to be pretty closely related to your persistence logic or your persistence layer, just because it contains the object that you're going to be saving to the database. So I'll just talk a little bit about what I'm building right now. First steps that I took into writing my first attempts at actually writing the model layer, and where I'm at right now is I'm adding functionality incrementally by trying to extract that into interfaces, and I'm getting a good feel for Golang interfaces that way. Specifically, I'm going to focus on the problem of data migration, migrating data that's serialized in your database. And then there's going to be a plot twist at the end. And also questions are, of course, welcome at any time, so feel free to stop me. I'm told I ramble and skip over details. So,
real quick, is it a plot twist if you told us it's a plot twist?
Yes. Do you know what the plot twist is? Maybe there is no plot twist.
Nope.
Yeah, that would be
You're always expecting it to still come.
Hey, React, yay!
Yeah. Did you have a question? Oh, okay. So what I'm building right now is essentially an advertising, redirection, and analytics service. So my clients will be buying ads online. When somebody clicks on that ad, they get sent to my redirection server. I do a little bit of processing on it. For example, I reroute clicks based on input parameters, or I detect bot clicks and block them, and I try as fast as possible to redirect the user to their destination landing page. So that's one of my server side. That's one of my server components. Another one is a REST API that powers my web front end, and another one is an image server that it gets pinged whenever like a sale or a conversion happens or an ad impression happens. And all of them are, of course, written in Go, and they all talk to React, which is the main database for my system. And just for the purposes of this talk, or at least the first part of the talk, you can think of React as just a general purpose, just key value store. And its main purpose is to take two parameters, key and a value, and save it to a database, and you can trust that it does that. Really, a lot of the ideas that I present here will be, you can use them not only for something like a key value store like React, but also maybe a document store like MongoDB, and you could even possibly use them for a relational database if you want to. But if you're actually using a relational database, you might want to look into actually using a real ORM, because they'll provide a lot of cool stuff for you right out of the box. So my initial thoughts when I started the project, It was actually one of the first things that I started working on in the project, just because it was a prerequisite to writing all of my resources, and it was one of my first kind of battles with the Go language. I came in looking for an ORM, and I had this idea that my model needs to know how to save itself, just because that's what I was used to. Rails Active Record. If you're familiar with backbone models, it's not technically an ORM. I guess maybe you wouldn't call it that, but it's a model layer, and it knows how to save itself, persist itself to a REST API. And I also had this kind of notion that whatever my models would be, or whatever objects represent my domain models, they would be kind of like an opaque data structure, and they would have getters and setters. And the reason for that is that I was kind of used to those getters and setters doing a little bit of work behind the scenes, aside from actually their main function of setting the attribute for me, setting the attribute value. That can be anything from automatic validation of data, maybe setting a dirty flag on a field just so that when you click save on your object, you do the minimal update, the most minimal update possible instead of sending the entire object over the wire. And I guess for the most part, I really missed inheritance, and I really had this idea that I needed some kind of model superclass for all of my objects. And I was coming from the perspective that, so let's say I have two models, right? I have an account model and I have a user model. And I know they're models because I call them models. And I needed for the program to understand this. But it was kind of backwards, because at that point I didn't even really know what it meant to be, for an object to be a model within the context of my system, because I was still trying to solve very basic questions like, will my models even have a way of accessing the database, for example, or right, will they be opaque data structures, or can you just modify them as you wish? And so I was kind of working against myself. I felt myself battling the language. I felt Golang kind of pushing back. I kind of felt Rob Pike just controlling my brain from thousands of miles away and laughing while he does it. So I decided to just conceptually take a step back, take a breather, and think about what I really wanted to accomplish. And I decided to just start from the data. And what I really need at the very core of my model layer is an in-memory representation of data. So Golang has that. It's a map. I need it to be serializable. And so that requirement actually changed from the model needing to know how to save itself to a database, which is pretty complicated. You have to think about a lot of stuff, to just make sure that there's an easy way to serialize it, because I'm in the context of, I know I'm using a key value store, and I know how to save a string. And so if my model knows how to convert itself to a string, I'm essentially done. And so that kind of provided a little bit of clarity and simplicity. And I'm still using a map. And then another requirement was that I do want statically typed attributes. So you just convert the representation of that to a struct. And I guess the idea was that you start with the most minimal representation of your data as possible. You think about what you need it to do, what kind of requirements it has, and you incrementally change the representation of that data based on what behaviors it needs. And I know that's kind of a lot of mental gymnastics just to pretty much get to the point where I have a struct that represents a model. But it actually did take me, it did take me that long to get to the point where I realized that this is pretty much all I need to start programming. I can start building my API. I don't need a complicated ORM or a third-party dependency. You can actually get pretty far, and at least in terms of what I defined, or what we described earlier, the model layer, it already exists, and it's just a collection of structs. And just coming from the perspective that there's probably going to be further behaviors that I might want to add later. And I'll use the Go concept of just interfaces. When I find that I need a new behavior, I'll define an interface for it, and then I'll try to have all of my models implement that interface. And hopefully all those behaviors will be orthogonal to each other and won't really interfere with each other. And so the first kind of non-trivial behavior that I actually wanted to add into my models came from the problem of trying to migrate data in schema in serialized data that's already in my database. So just hypothetically, I want to kind of just a thought example of demonstrate what kind of like how this is actually a problem in production systems. If you, let's say you have a web service, right? And you have an account model, and you're pretty popular. You have 10 million accounts, and you're only in the U.S. so far. And at some point, you want to go international, and you decide that I don't really care about the state of the account anymore. And this is like Texas, California state. I want a country field, and you can solve this at the application level. You can always just keep the state in here, state field, add a country field, and ignore the state field. But ideally, you would actually clean your data up so that your application and your data is maintainable. So you do need a way of changing all of that serialized data from this schema to this schema. And so I just want to make also the distinction between data migrations and schema migrations. Most of the time, a schema migration will also be a data migration, but a data migration might be easier because an example of a data migration would be if the state, if I needed to change all the state fields to be from abbreviated states to full-length states, they would still be strings. But right now, I'm actually changing the schema, and so here's just an example of how I would do this with the current model layer that we defined, just a bunch of structs serialized, 10 million structs serialized into the database. You would first have to temporarily change the schema to be the union of the current schema and the desired schema. So you would have a temp account maybe, or no, it would still probably be called account, but it would have both the state field and the country field. And you would also have to make necessary application level code changes that know how to interpret that temporary schema that contains both the state and the country. And a lot of that will be domain-specific logic that it could be anywhere. It can be in UI. It can be in the UI that expects some kind of data format. It can be in deserialization. It can be wherever. And so once you make those changes, you have to deploy all services. And at this point, you should be safe to run a backfill script that does your actual copying or your kind of migration function that looks at the state and it says, okay, if the state is set, then I'm going to set the country field to USA. If the state is not set, then I'm just going to leave the country field blank. And so I run that backfill script. At step 5, you find out if you missed anything in part 2 because things will start breaking. PagerDuty or maybe. And so if nothing breaks, then you actually have to do 2 cleanup steps. Well, one is deploying all the services. Well, one is removing the old field from the actual schema and reverting your temporary application level changes and redeploying all your services. So all in all, just a pretty simple schema change. It can take over a day to do all of this depending on your scale. And it can get pretty annoying, and it's also kind of, it's more risky because it requires an operations level change. So this is a great example of something that would be great to solve at the model layer, but I wasn't really sure how to do that. And I stumbled upon this. So the engineers at Braintree, they wrote a client library called Curator. And it's a Ruby library. It supports React and a bunch of, a few other data stores, I believe. But they solved this problem with something that they call lazy data migrations. So what you do in lazy data migrations is you wait until the very last moment to run your migration functions on your data. And this requires that you add an extra metadata field to your serialized data format called a version. Well, I call it a version. So basically what it looks like in my Go version is that you have a static array of migration functions in your code. Every migration function is named, and it's append only. You can't ever change the order of existing migration functions. And when you save a model, you serialize it, you encode the latest known version, and maybe weeks later you deserialize it, and that array in code may have changed. And so your code is going to look at the version that the model was serialized at and compare it to the latest known version in the migrations array. And it's going to fast forward, if it needs to, it's going to fast forward your model to the latest version. And only at that point does your type system actually see the data. So that was the first thing that was the first kind of behavior that I wanted to add into my model layer. So definitely inspired by Braintree a lot. What I wanted to do was just first define an empty interface. And the way that I wanted to build it was I just wrote a function that performs an operation on a model or on that interface. I defined my function signature right here. I wrote a bunch of code. Basically, it was just, I can show you after the slides are over, but it's simple loop code that looks at the migrations, and it basically does the algorithm that I mentioned. And it runs the input map through the migrations, and it returns the output map. And the caribou is my interface name, and I named it that because caribou is a type of animal that migrates.
Quick question, what is your output interface? What is kind of the expectation of what's coming out there?
So my migration functions work on maps, and they take an input map and they return an output map. And I'll talk a little bit about, is that what a transpose is? Oh, okay.
Mathematics.
Okay.
Well, I guess that's what I'm asking. Is it a transformation in the sense of given an input, it's going to come out transformed with the same set of keys with transformed data in the map?
It's going to be any kind of transformation. It can be a schema transformation. Fields can be removed. Fields can be added.
It can also be data.
It can also just be data. Yeah.
Gotcha.
And at the very end of my fast forward, I'm going to call fast forward map on whatever I deserialized. I'm going to get this output right here, and I'm going to fit that into my struct, which is already in the type system. And I'm going to also talk a little bit about the type signature for this function and why this fast forward map isn't actually defined on the interface. And this has a little bit to do with how I actually implemented. Can you guys see that? Yeah. It has a little bit to do with how I actually implemented this functionality. But just as a example of a migration, you have an account, you have a country string. So our code already is at the stage where we don't care about the states. We only care about the countries. Here is a sample migration function that's defined on the account. It has an array of one migration. The migration is named state to country. And it takes an input map, returns an output map. It checks to see if the state exists. And if it doesn't exist, that's not right? It should be. Yeah. So if it exists, we should set the country to USA. And we can actually run it here.
if you were doing this on all subnational polities, that is to say, all provinces, all states in the world, and would you need to pass it something like a hash map that will tell you that this thing, this subnational unity, subnational polity belongs in this national polity?
Yeah, as long as it never changes, it shouldn't be dynamically updating, because that would make this non-deterministic. And so here's one utility function that I have for my models. It takes a byte array, JSON byte array, and right here it has Texas. And so this is an example of a string that we would, kind of an old serialization that we would pull out of the database that doesn't actually fit into our current type system. And our load JSON model, I can show you the implementation of this afterwards also, will detect that this migration needs to be run on the deserialized form of this, and it will then turn it into a map and fit it into the account struct. And right here we can see that even though there's nothing in this string that says USA, when we print the country out, Go should print US of A. So that's how that works.
JS?
This right here. I'm actually,
To run it?
to run it, I'm using the Go package. It's called the present package, and there's a markdown-like syntax for just generating slides. And
That's live code.
yeah, and one of the features is that it reads your file system and it runs code. And so I just have a slide right here called play, and it just plays that code. Oh yeah, and so this is the interface issue I was talking about. The way that I implemented this was that I have an embedded struct that contains my version. I have a top-level struct that has an account that's just an account. So something like this. Oops. That's my plot twist.
I did not see that coming.
It's a total surprise.
Okay, so my space bar isn't working, but yeah, you get it. So I have a top-level struct, and the way that I specify that it's a model is by embedding the metadata struct in it. My metadata struct, let me just switch to my code. It's a lot easier that way. My metadata struct has a version field, and it implements the Caribou interface. And the Caribou interface it's right here. Returns a list of migrations, and it returns a current version, and you can set the current version. And I determined that these are the methods that I wanted on my interface by first trying to implement the fast forward map function. And I determined what functionality my interface actually needs, and then I implemented that. And as you can see, the implementations are very small. And for this commented out snapshot, it's also pretty small. Caribou. And so one caveat with embedding structs within each other is that you can define, for example, migrations on the model metadata struct. And when you embed that into the myAccount struct, myAccount, you can call account.migrations. And you can override that function. You can override that method by defining myAccount migrations. But you will never be able to define a method on model metadata that accesses fields from the upper struct. And that prevented me from defining fast forward map on the Caribou interface. because I needed a way of actually accessing the data and performing migrations on it. And so that's just an example of a pattern that I used, embedding structs, adding functionality to my models. I'm getting by without an ORM so far, and it's been working pretty well. So the plot twist is that I'm using React right now, and I introduced it as a key value store, but I'm not actually using the key. I'm not using it as a key value store. I'm using a special data type that React provides called CRDTs that they do actually understand your data. You can save a map to it. You can update fields in a map. And the way that you update this, the write semantics there are, you don't write the value as a whole to React. As a programmer, you write update, you construct update commands, and you have to send them to React, and React will merge them and do all kinds of crazy stuff that Mark can tell you about.
If you really want to know the ugly details, please ask.
But so it no longer becomes true that all you need to do is provide some kind of model that's easily serializable into a string, and then you have easy persistence, because now you need to generate these update commands. And what you want to do, the way that you want to work with your models from your code is you don't want to generate these commands. You want to set fields. And the way to solve this, I actually got this idea from the JavaScript library React, which also kind of a similar way does kind of a diffing algorithm against what you have in your DOM on your web page and what you want it to look like. You diff it and you generate commands that updates the state. And so this is kind of similar. And I wanted to implement that as a snapshotter interface. And what that does is whenever I load a model into memory and I deserialize it, I also, into metadata, save another field called snapshot. Where's that? And this code is a little messy here. But when I use this function to load a map into a model, I save the snapshot. And I have a utility React, a React utility method that compares that snapshot against the current struct using Go's reflection. And it constructs the React CRDT operations and returns them for the React client library to use. And that code is also going to be on GitHub, but I suggest that you don't read it. But that's it right there. And that's basically my story of how I'm getting by without an ORM. And if you notice that these the CRDT React kind of writing semantics are very similar to how you would update how you would update rows in a relational database. And so that kind of goes back to the dirty tracking that I mentioned earlier, that maybe you want setters in your models that will keep track of dirty tracking, and they will be that will provide your models with enough information to be able to do smart updates over the wire to your database. But having an opaque data structure like that may not be the only way to actually achieve that goal. And so a sort of diffing algorithm like this might achieve the same thing, and you also get the benefits of a plain old struct as your domain model. And that's it. Do you guys have any questions?
Does this mean you have no searchability? I mean, are your strings in React? I don't know much about anything about React. Does this mean you can't search your database? Right?
I'm currently not using the search feature. React is actually pretty powerful, and I think they do provide searching over data types, right? and you can create indices.
With caveats, but yes,
Yeah.
you have to define indices, and that's what we query on, is whatever the user-defined indices.
Mm-hmm.
So,
But in this case, with your model, you're serializing just basically a string, right? Which means reality.
Right. There's no searching. There's no querying. I'm looking up by key. Yeah.
Okay, which means your application might not need it. You're definitely getting by right now.
Yeah.
Which is cool, but if you wanted to add that, you just
Exactly.
change your interface.
And yeah, and React has an idea of secondary indices.
Even with a complicated app, you can always just farm out something like ES or whatever, Solar,
Mhm.
like, right? Because you can just have something else that's indexing, and you just go, what's the ID for that? And then you go figure out.
So yeah, so there's Yokozuna if you want to see
Mhm.
it with Solar inside of React.
Mm-hmm.
So,
Yeah. So I'm using it right now. I'm trying it out. I'm weighing Yokozuna and Elasticsearch, and
right on.
yeah.
So this is cool. This is cool. I have a general question, which is: do you think that the type system is helping you here, or do you feel like you're like fighting the type system, just generically?
In the code that I'm writing to implement my model layer, I'm not really using the type system. I'm pretty much converting everything to maps and applying kind of my JavaScript complete no type system skills in order to just but I guess the goal is that the rest of my code takes advantage of the type system.
So you talk about this is being used to power an ad platform, essentially, correct?
Potentially in the future.
Potentially in the future. Very diplomatic answer. So I guess to kind of couple off of his question, I'm not sure if it's a personal preference and I have no empirical data at all, really. There's been plenty of research to suggest what I'm about to say, but that don't mean it's true. I find myself getting a little itchy when I start to, the moment I have to type the word interface, empty interface more importantly, I get a little itchy. To me, it makes me wonder, is there another way to approach this problem? And I see that you're very much relying very heavily on empty interfaces and reflection, which is very interesting. Do you have any concerns about performance and scalability based on the fact you're looking at an ad platform and potentially scaling could certainly be a concern at this juncture? You're serving ads to hundreds of thousands, millions of people. Any concerns around that?
So
You can rewrite it without reflection then.
Right, that's
mean,
true. That's
I mean,
right.
really,
Solve the problem.
I could,
with
yeah.
that, right,
If
obviously.
you one of 9, most everyone does something.
It
Yeah.
also reminds me the Go JSON serializer uses reflection.
Yeah.
And the truth of the matter, from what I can tell, people who really need the speed, then they go up and they directly
Right.
Yep.
Right.
serialize their object.
Well, I mean, he's using JSON serialization and
Yes,
reflection and empty interfaces for every.
mhm.
Right. You see what I'm saying? That's not to say you have a problem. More just kind of from a philosophical standpoint, how do you feel about using empty interface?
So why is that a problem then?
Well, an empty interface is suddenly the type system. Everything has to be coerced into its appropriate type. Then under the hood, at some juncture, it's got to figure out what this is to know what to do with it.
It's like .NET using type object.
Right. Yeah, or Java using object.
And the practical difference is really just performance. I mean, that's really what it comes down to.
Right.
I mean, we can talk about type state and all that, but the
Performance
thing
is
that's really
one.
killing him, could kill him someday.
Yes,
is
performance.
performance.
Other than that, there's just a readability question then past that. 'Cause
Yeah.
To me, then you're typecasting all over the dang place.
Yeah.
Essentially, which is.
I look at this as more
library.
I look at this as more library code that I'm not going to be touching most of the time,
Right.
and most of the time I'm going to be writing application code. But the other side to that is library code gets invoked all the time, and you're right that these interfaces, they could potentially become a problem. So I'm still a newcomer to Go, and I'm still trying to figure out where the potential performance issues could be.
I think you're doing the right thing by not trying to address a problem that you don't necessarily have yet.
Right.
Yes, I'm sorry.
Sorry, I want to ask you a question.
Sure.
Question. You're mainly talking about vertical performance, though, right? Like this has nothing.
Well, no,
to do-
that's like how many nodes do you need to serve? How many web servers do you need to have to serve your app, right? It becomes a cost of doing business thing at some point.
Well, sure, but it's not a. It's but you're still talking about improving vertical performance so that you can use
It's
those
density per
It's not
server.
talking about the fundamental nature of the
Yes,
problem
yeah.
so that it makes it harder to scale.
I mean, there could be an overall latency SLA you're not hitting. So most ad engines that I work with, they go for under a millisecond for the 90-some percentile.
Sure.
And you could eat up a fair chunk of that doing reflection conceivably, depending on how many fields you have. And I don't know if the performance semantics, but I know in Java you definitely could start to hit a level pretty quick.
That's correct. Yeah. But you're
So
still
that wouldn't
talking-
even be a vertical conversation. That would just be a pure, I have X amount of budget for latency conversation.
I mean, at some juncture, it does turn, practically speaking, it turns into a vertical conversation eventually, right? I mean, it's kind of hard to avoid. At some level of scale, this is going to impact your vertical conversation.
Use a
right?
tree
Right,
node.
but the data structures and stuff he's talking about don't include, like, they already support horizontal scalability because that's actually what React,
Yes.
the CRD
Yes.
feature of React,
Well,
which is like,
and even then,
By and large.
his horizontal scalability, we're talking about the web layer here, right? We're talking about the REST,
Right.
REST service anyway. So it's
Exactly.
already horizontally scalable, period. That's what I meant by like, it just becomes a density conversation at that point of what's the cost of doing business
Sure.
based on, well, I could do this with 3,000 nodes or I could do this with 50 if I optimize.
I
Right?
think we're saying the same thing.
Yeah.
Yeah, in the end.
Violently agree.
And I think, yeah, exactly. And I think what this is kind of turning into is you start, you can't throw a stone more than 5 feet anywhere on the internet right now without reading some white paper that someone has said, well, I was using Go and I had to do the following things to really optimize performance at certain X scale here, right? And they all end up kind of, it's interesting, the pattern I've seen is they all kind of end up going the same direction. They get away from this.
Yeah.
9 times out of 10, they go, okay, we had to get rid of the reflection, we had to get rid of this, we had to be careful about our GC
I see.
polylines, we had to be careful about, we kind of have this common list that's growing more and more that says, all right, here's the pitfalls when you're using Go and writing this very kind of thing to be careful about, really.
And I'd actually love to learn more about that. And I'll probably be able to answer some of those questions once I actually launch.
6 months down the road.
Yeah.
You see money, then you can start
But
worrying
you
about
also, if you see companies that write that kind of blog post, you look at them, they're all multi-million-dollar
Yeah,
companies.
They're going to
They've
scale
already-
problems.
They made the money
Yeah.
to now come back.
Yeah.
They're now getting to the questions that you brought up of, all right, what's your cost of doing business? And
Right.
it was getting high, and it was impacting their customers' outcomes.
Yep, bingo, yeah.
So you don't have that
Right.
problem anywhere close yet, so I agree. Solve that problem when you get there.
Right.
The fail well.
And I think there's some room to improve this code. Like you mentioned, maybe not use JSON serialization, use some other kind of serialization format. My question when I was thinking about this earlier was how do I'm going to have one type system definition of my object, and I do need to perform this migration if I'm going to be doing lazy data migration at all. I need to have some kind of intermediate representation, and I need to perform those operations on something. And so maybe I could use some kind of binary serialization format instead of JSON, but I would probably still have the Go maps.
I know that. I'm working on a system now that I built an integration tier in Go, and I am doing a disk-based caching, but I did opt for binary serialization as opposed to JSON. That was one of the reasons there. Once again, it was more of a, you know what, I don't need JSON, I don't need this to operate anywhere. I just need to cache the dang thing, so binary just felt right.
Yeah, and it's definitely going to be an adventure.
Yeah, no, it's cool stuff. I mean, I like what you've taken with the Ruby library and the lazy. That's pretty clever, actually. It's pretty cool.
I think that's
Yeah,
really,
it's
really
a
neat.
good pattern, and it's there's a reason why they did that. I mean, you see people re-implement
I've not
something
seen
like
this
this
before. It's
over
cool.
and over again. And well, in the Java space, right? Typically, I would see people re-implement lazy type migrations over and over and over again themselves, and usually screw it up. You know, because they're not borrowing from prior art; they're appending it on their own.
Do you see, coming from I work for a very large company that certainly does not believe in lazy migrations at all. We very much believe in highly complex migrations where it's all done by hand. But anyway,
Work harder, not
I'm
smarter.
not saying there's not
24
automations in
hours.
place or tools. I'm just saying that it takes a lot of work to get a lot of testing to make sure they're all accurate and correct.
but I still.
Is this a growing pattern that we kind of start to see really catch some steam and get some maturity behind?
Well, so I actually see this a lot in big data setups. Like I actually see it quite a bit, particularly anything where it's. I'd be interested in what Mark has to say, but just because of my background at DataStax with like kind of pro services type stuff, I do see a lot of people do. We're going to make a giant cluster that is a data service cluster, and so then they just do a generic key value style format for that, and they really just do have some serialization format, and they do this, and it's really not a common way to go. Yeah, it's not a common. And I was doing stuff similar to this. Again, by hand and not looking at prior art, probably doing it wrong half the time, a long time ago, just with messaging. Having to maintain multiple schemas. It's a way that you can do deployments without being down. Right. That's the main point in this case.
Oh yeah, I very much understand the reasoning behind it, because like I said, our deployment times are reflective of the fact that we have to go down.
So anytime you start getting continuous delivery, you start having to have the ability to survive. You start having to have the ability to at least have an application that can understand both versions of messages at minimum. Right. And so once you've done that, you might as well just go, up convert. And that's usually how it happens, as opposed to like somebody consciously going, let's make lazy migrations and do this the right way. Literally, it's just somebody has to go, well, we don't want to be down, so we need to support both versions. And then you go, and you just, as soon as you read version 2, you upgrade to version 3, and you just put that in the runtime. And you have to balance that out against speed, and you have to go, because you mentioned the whole map thing. A lot of times you have to query an external data source. It might be something that you don't have a choice. It's something that's too big to dump into a code,
to a memory structure,
into a memory structure. And so you do have to go make an external call.
I consider that like large blob structures, for example, or like large blob data, for example.
Yeah, or just you just gotta look through like a few 100 million records, and you don't really want to do a match against a few 100 million records.
At runtime.
Well, at runtime you can do it. You just have to make it a remote call, rather than doing.
GitHub's had a few big downtimes during these things.
Yeah, I'm guessing in React you have the same. The Bashflow space, you guys have the same common pattern.
Yeah, that's cool. That's becoming an established pattern. I thought it was just Braintree doing this.
Well, so
by the way,
I would say so. I've heard of their stuff. I would say that they probably have actually thought it through. There's a difference between like I wrote something because I needed to write a service that had support to the versions of messages. Right. So like that's sort of the established pattern is writing services that have support and old messages because they're you're going live and you're deploying and your emitters may not be all deployed at the same time as your receivers, and so that's really where most of it is.
And that's the kind of the deployment kind of checklist that I mentioned there. One thing that assumes is that whatever is doing your deserialization, if it has an extra field that your serialization or your schema doesn't expect, then that will just crash and not work. And so I've experienced that with Avro trying to talk to MongoDB. I think JSON is. I think Go and JSON is a little bit smarter and it doesn't crash in that situation. But I just.
That's a good point too. Yeah. Being able to ignore extraneous data that you don't need is a very important aspect. You want to support that scenario.
That would seem really useful if you have incomplete information about whether your data is clean or not.
It's interesting to me that this almost feels like you have put a lot of time and energy considering the operationalization concerns very early in the process.
Smart.
It is smart, actually. You don't see it very often. It's kind of fun commenting on it. In fact, in my experience, it's kind of rare.
Well, I've dealt with the operational headaches of it at my previous company.
Okay.
So
you are working off past experience.
Yeah.
That's fantastic. No, that's good stuff.
Yeah, really good.
Right.
Any more questions? All right, thank you.